Hi, everybody. So I'm Ori, the CTO of Pynt, and I'm here today to show you a quick demo about how to integrate Selenium and Playwright test to Pynt. So what is Pynt? So Pynt is all about automated API security testing, which means your company is developing APIs, right, for your applications. Those APIs might have some vulnerabilities that hacker might use to attack your application and run code, breach data, whatever hackers will try to do on your applications. And Pynt is doing this for you to make sure that your APIs are not vulnerable. Let me show you a brief description of how it looks like. Okay. Pynt is attacking your APIs by first learning your APIs and understanding what your application is doing and how it behaves and how it runs. And once we take a look at that and analyze how your application works, we'll attack your APIs and give you the report. So how do we understand it? How we understand how your application is working? So to understand how your application is working, we are looking at API traffic to your application. Okay, real API traffic that works, actual requests and responses, valid responses from your application. And by looking at that, we can analyze this traffic and build from this like the model of how your API behaves. Once we do that, Pynt will detect those APIs, sending the malicious payloads to your application, and from the responses, we'll understand if there is a vulnerability or not in your application. We have many ways to integrate traffic into Pynt. So, for example, as I said, Selenium and Playwright are developer-oriented traffic like QA and end-to-end tests. This is one way to connect to Pynt. We can also connect with Postman, and this is a demo I've done on the previous years here. And we can also connect to other sources of traffic, for example, server-side traffic, like sniffing traffic on the server side. But today we're going to focus on more on the developer-oriented traffic. Okay, so today I will show how to run Pynt with Selenium or Playwright tests. And the first thing you need to ask yourself is why? Why, if I have developed some UI testing on my application, what is this to do to security testing? So as I said before, we're running the same way that an attacker will look at your application. Okay, attacker will once he wants to attack your application, he will look at the traffic, will understand how things work, manipulate some data, see how the target responds, and then continue with the attacks until he finds some vulnerability. So Pynt is doing the same thing. Now, your UI tests, which are UI tests, right? You're checking buttons and forms and filling stuff and to make sure that the front end is behaving correctly. So these actions generate a lot of traffic to your backend, a lot of API calls, things that you're not aware when you're writing the UI tests, maybe. So this is a great source for traffic for Pynt because it covers a lot of APIs and it's just the right traffic for us to do the security testing in a great way. So this is why you would want to do this. So basically, we are recycling some traffic that already exists, something that you already generate, and we use this output to run security testing automatically from it. And this way, it really simplifies the way to do those testings because it don't need to do anything else, just connect Pynt with that traffic. So let me show you how it works. So suppose I have this very simple Selenium test that I've written in Python. And this is some really simple UI testing. It's just testing some application. It's a really vulnerable application created by OWASP to teach about API security issues. It's called Crappy. It's some car management application. And my very simple UI test is just logging in with two different users, and each user is checking the location of his vehicle, and basically that's it. Now, if I want to run Pynt and do API security testing from this UI test, So we just run this command. Okay, so I'm wrapping the command I used to do the UI testing with the Pynt command itself. Let me show it works. Okay, so now I'm starting Pynt. In this case, I'm using the Pynt CLI, which is using the Docker image of Pynt. So the CLI is automatically taking the Pynt image, running the container, and now is running the UI test through that container. So running it as Pynt is running as a proxy, and now the Selenium tests are sending all the traffic into Pynt. We're now listening to the traffic, and now we're starting to do those testing and those attacks. So this was a really short test, so this is why it was relatively fast. And we're getting the results here, so pretty fast. And let's take a look at the results here. And so we can see we've seen 4 different endpoints from the application, okay? And we found vulnerabilities in 3 of them. Let's focus on one vulnerability. For example, this one, which is a business logic use case. It's like a BOLA, okay, or IDOR, which means one user is reading the data of another user of another tenant, and something that's not supposed to happen, of course. In this case, one user was reading the location of the other user's vehicle. And so we were able to do this attack just by analyzing. You don't need to configure anything. There's no configuration to Pynt. You just need to provide us the traffic. So from the traffic, we analyzed that we've seen two different users, and each of them is accessing his own resource, his own location. And by looking at the traffic, Pynt understood, okay, I have 2 users here. Both have their own private resource called location. And now let's see if I can manipulate and create a request that allow user A to read the location of user B. And that's exactly what happened here. And from the response, we understood that this data is the same data that user B is read from his own location. So Pynt decided that this is an actual finding and reported on it, which is pretty cool. Those vulnerabilities are almost impossible to find by any static scanners, and most dynamic scanners promising that they find those, but it's very, very hard to find, and we're really focusing on finding business logic issues above all. So this was the run, and these are the results. Now, what I needed to do in my code to enable this. So since we're running as a proxy here, well, we need to tell our Selenium to go through Pynt proxy when Pynt runs. Unfortunately, both Selenium and Playwright don't read environment variables of proxy routing. So we need to do the routing ourselves here to change the actual test to do the routing. But you can take this example also from documentation. So what I usually do is looking at this environment variable, which Pynt exports when he runs, and then I'll do this proxy configuration only when I'm running my test from Pynt. And that enables me to still keep the UI testing can run normally. If I just run it as I always run it for QA, it will not go through the proxy. So I need to add this information to the configuration of the web driver. In this case, it was Chrome. It also works with the Firefox. And once I have this, when I'm running, as I showed you before, so it will route all the traffic through Pynt, and that will allow us to see the traffic and actually attack the endpoints. All the reports are, of course, uploaded to Pynt dashboard, and you can see all the vulnerabilities of this application and all the catalog of the endpoints, everything in one place. And from here we can take a look at those vulnerabilities. And this was the vulnerability that we've seen before, showing you the evidence. I mean, that the request and the response that actually created that Pynt created to find this vulnerability. We can reproduce it with a curl script. We can open a Jira ticket from here. So any actions that we can do from the dashboard to manage the life of this vulnerability. Cool. So this was for the Selenium part. And let's take a look at Playwright. So Playwright is basically the same thing, the same concept, right? It's the same UI testing. And let's take a look at the script here. So in this case, it's a JavaScript test that I've written. And same thing, I needed to add the proxy information to export it when running with the Pynt. So when running from Pynt, I'm telling it to use proxy, and then if you use proxy, then route the traffic. So that makes me, again, same thing in the Selenium. I can run the test normally, and when I run it with Pynt, it will go through the proxy, and I will run it here. In this case, my test is a very, very simple short test that is running against another vulnerable application called DVWA, Damned Vulnerable Web Application. And in this case, I'm looking for an SQL vulnerability. Okay, so same thing, running it with the Pynt command, wrapping the normal request with the Pynt command, running it, and Pynt, same thing, runs the Playwright testing, recording the traffic, and doing the scan. Okay, so to find the SQL injections, Pynt, first of all, looking at all the parameters in all the APIs to see which one looks like something that should be injected with injection-based attacks. Once we see that, we'll try to inject some payloads just to see if there is something behind this endpoint. If there is some database, it should act differently. And once we decide that there is a database and we understand that it is a MySQL database, we'll attack it with a specific MySQL attack. In this case, we're injecting sleep commands. So, of course, if we're finding a database, we don't want to destroy it, we don't want to delete it, we don't want to ruin things, we just want to find a vulnerability. So we're sending sleep commands, which will cause the response to delay in the amount of seconds that we're sending it. So if there is a database behind this API and we're sending that sleep message, so it will hold or wait for the seconds that we specified. And in this case, we're sending the 4 seconds. If we think the response is getting back in about 4 seconds or more, we understand that there is something here. And then we try this with 5 other different timeouts just to make sure that it wasn't some network delay or some lag or something like that. And once we see that those 6 timeouts really were as we expected them to return, only then we'll alert on this vulnerability. Both of these examples that I showed you here are on our website, on our documentation site, in Pynt.io. This demo, feel free to jump to our booth to ask our questions. We'll be happy to see you.